Okay, so here's the free response for this is the Unit 2 test for AP Calculus, the test review. So the derivative of the polynomial f is represented by the equation here. So they're giving us the derivative instead of you having to take it yourself. Additionally, they give us an x and a y value that we'll probably need to find a tangent line later. And the graph of f is concave up at x equals 1. This concave up, like a cup, is this picture, and we're going to use this to answer the very last question. Use this information to answer the following. Okay, a relative maximum occurs when f prime changes from positive to negative. So all we have is f prime. We don't have a graph, so we need to do a sign chart. And in order to do a sign chart, we need to know the critical numbers. So the critical numbers tell us where there's a max or min. We get the critical numbers by setting the derivative equal to 0. Because when the derivative equals 0, we have a horizontal tangent line, okay? All the pieces should be coming together for this test. Horizontal tangent line, which means there's a max or a min, max or min, okay? So when we set this derivative equal to 0, we have negative 2x equals 0, which means x equals 0, and x minus 3 equals 0, which means x equals 3, okay? So our critical numbers are 0 and 3. We know it's a polynomial, so we're going from negative infinity to positive infinity. We need to plug in numbers left and right in each of these intervals. So left of 0 is negative 1. And when we plug in a negative 1 here, we have a negative, sorry about that, a negative times a negative is a positive, and a negative squared is also a positive. So then from here we go positive times positive is a positive, which means f is increasing. Okay. A number between 0 and 3 would be maybe 1 or 2. So if you plug 1 or 2 into the first factor here, you'd get a negative. And then this second factor will always be positive. So a negative times a positive will be a negative. A number greater than 3, 4, again 4 plugged in here would be a negative. 4 minus 3 squared would always be a positive. So again, a negative times a negative is a negative. Okay, this is to help us answer these questions. You need to always show all of your work in order to get full credit. So at what values of x does f have a relative maximum? 0, because f prime changes from, from positive to negative, here and here. It does not have a relative minimum because you still have to justify your reasoning even if the answer was none, if there's a spot to do so. F prime never changes from negative back up to positive. On what intervals is f increasing? So we start at negative infinity because the fact that this is a polynomial. So the derivative is positive from negative infinity to 0. So that's why f is increasing. And you can say f prime is greater than 0, which means f prime is positive. You cannot say because f is increasing or because f prime is increasing would be really wrong. It has to be positive. If you use the word it anywhere on this page, you're going to get marked wrong, okay? If you say it changes from positive to negative, that means that you're not clear if it's f or f prime. So do not use the word it on a calculus test, okay? Where is it decreasing? You may not say from 0 to infinity because it's equal to 0 at 3. And f is decreasing when f prime is negative. It's not negative at 3. It equals 0 at 3, so you have to skip over the 3. So from 0 to 3, and then 3 to infinity. Okay? All right, I'm going to do D. What is the equation of the tangent line at x equals 1? What do you need for an equation of the tangent line? We need y minus y1 equals m times x minus x1. So they didn't give us the original function, so they had to give us the point, and the point they gave us was f of 1 equals negative 3, and that's going to be your x value and your y value. So we have y minus negative 3 equals m, we don't have that yet, x minus 1. There go the lights. Will it adjust? Let's see. That's pretty good. Okay. m is the slope, and this is the tangent line. So the slope of the tangent line, what's the slope of the tangent line? The slope of the tangent line is f prime of 1. Okay, do we have f prime? Yes, we do. F prime is the derivative. It's given in the question, so we're going to plug in 1 into the derivative. Negative 2 times 1 times x minus 3 squared. Negative 2 times 1 is negative 2. Negative 1 minus 3 is negative 2, and negative 2 squared is positive 4. So we have 2 times 4, negative 2 times 4, which is negative 8. And since that's the derivative, when you plug in 1, negative 8, then negative 8 is the slope of the tangent line. Slope of the tangent line is the derivative. So there we go. You don't have to solve for y. We actually like it better for this if we don't distribute the 8. That's my point. What's your point, lady? Don't distribute the negative 8, okay? Use the equation of the tangent line to find the approximation of f of 1.1. So we're going to plug 1.1 into the tangent line. 1.1 minus 1. Okay, there's no calculator, so all of these are very doable, okay? 1.1 take away 1 is 0.1. So now I have y plus 3 equals negative 8 times 0.1. Negative 8 times 0.1 is just negative 8 times the 1, and you keep it in its place. So we have y plus 3 equals negative 0.8. How do I get y by itself? It says y plus 3, so I need to subtract 3 from both sides. So y will equal negative 0.8 minus 3. These are both negative, so we're going to add the numbers together and keep it negative. So we have negative 3.8. Okay. Hey, is this estimate greater than or less than the actual value? That comes from the phrase concave up. So if something is concave up, it looks like this. And what you need to realize is that the tangent line, I'm trying to find another color, but look, all I have are green. Today's a green day, more green. Let's see here. I guess I'll just have to use a pencil. If concave up is like a cup, so concave up, look at these tangent lines. Any tangent line, no matter where it is, will be below the curve. So when something is concave up, then the tan line is below, the lights mysteriously came back on, below the curve. So the estimate of y equals negative 3.8 is less than the actual ACT, I need a T in here, right? Actual value f of 1.1. All right, cool. Let's do the next one. Okay. Consider the function 2 square root x minus 3 cosine. It's beautiful, yeah? On the interval from 0 to 2 pi, so you can see it go to like 6.28. The graph of f is shown on the right. That's nice of them. Show algebraically that f prime of x equals this. What does that mean? That means they gave you the derivative, and we just have to show the work. Isn't that nice? Isn't that nice of them? So, f equals 2. Now, I made you guys memorize the square root of x, so we don't need to, I made you memorize the derivative, so we don't need to change that to a 1/2 power because I made you memorize it, so we should have it memorized. Ready? Derivative. 2 times the derivative of the square root x is 1 over 2 square root x, okay, minus 3, and the derivative of cosine is negative sign, but instead of putting the negative here, I'm going to make this negative a positive derivative. So if you think about it, the derivative of negative cosine is positive sine, but if that hurts your brain, then don't worry about it. Okay. There's our derivative, but it needs to look like that. So what do you notice? Here I have two terms, and here there's one term, and there's a 1 there, and no 2's. So what happens to 2 divided by 2? They divide out, right? If you say they cancel, that's really not good enough for college. You have to say they divide out, or they divide to 1. Cancel, it means you don't know if it's 1 or 0. Well, Ms. Keener, I know. Well, that's the college professors are telling me. The kids don't know. So you have to say divides to 1. Okay. Again, I have two terms, and the answer has one term. So it looks like there's a fraction, and I have a fraction here, and I remember that in order to add fractions, we need a common denominator. The denominator for this one is square root x, and this one does not have a denominator. So I'm going to multiply this one by square root x over square root x. And now that we have a common denominator, we have one fraction, and it's going to be the number 1 plus 3. Let's look up here. Okay, yeah, the square root, I remember that. Nothing can go behind the trig function. Trig is going to be the last thing. Pretty? Good? Beautiful. Based on the graph of f, will the slope of the normal line drawn to the graph of f at x equals 4 be positive or negative? Well, let's go to 4. And before I get to the normal line, I need to draw the tangent line. So here's the tangent line, tan. And the normal line is perpendicular. So try and draw a perpendicular line here, 90 degrees, yeah. And I'm going to label it normal. What's the question here? Based on the graph of f of x, will the slope of the normal line be positive or negative? Okay, normal, it's going up. Oops, I couldn't see that part, sorry. So tangent's going down, normal's going up. Slope of normal line is positive. That's it. Okay, new question down here. Below is a graph of f prime. Determine the values of x at which the graph of f reaches a relative max or minimum. Justify your reasoning. So it'll be a relative max. F will have a relative max at x equals blank. So we need to go, and it's because f prime of x changes from positive to negative. This is a derivative, right? Oh, lights. Derivative, positive, 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 0, negative. So here at 0, it looks like it's going from positive to negative. So that's going to be this point, 3.325. 3.325. Did it ask for a minimum also? Okay, does it have a minimum? It needs to go from negative to positive. So if we're including this piece right here and we don't stop it, then this is a minimum here. So I'm going to have to write that sentence up here. F of x has a... Are you guys looking forward to, after this test, it's kind of taking a break from these sentences? They're not going away, but we won't be doing them every day. Yay, lights back on. I'm sure this is like a crazy video to be watching lights flashing on and off. Because f prime of x changes from negative to positive. Last one. Based on the graph of f prime, oh, I have 40 seconds. What are the open intervals which f is increasing? So you're going to write a complete sentence, but f is increasing when the derivative is positive. So that's going to be from 0 to 3.325. And f is decreasing on the interval from 3.325 to 6.148. Justify your answers. F prime is positive. Am I out of time? And this one, the f prime is negative. Okay, let's pretty much review, yeah? All right, answers to the multiple choice are also posted.